This is our day 9 video. It is for Monday, April 6th. We're going to be working with the double angle identities, which we have 3 of them: the sine of 2x, cosine of x, tangent of 2x. I just want you to take note for the cosine of 2x, I have 3 possible identities. They are these 3 right here. So if you want to go ahead and pause this video and get those down in your notes, that would be great. Once you have that, we're going to have 2 types of problems. I'll do examples of each. They're going to look like this. I could have something that has not a special angle in it, some kind of crazy angle. But if we notice and we take that crazy angle, 22.5, and if I take 2 times 22.5, that does equal special angle is 45. So I'm looking at double angle identities, and obviously right here, 2 times the sine of x, cosine of x is equal to the sine of 2x. So what I've got here is 2 sine 22.5 cosine 22.5, which will just equal the sine of 2 times 22.5, or 45. And quite simply then, that is just the square root of 2 over 2. And that's all there is to it. Another example could look like this. I'm going to have, again, an angle here that's not a special angle. So I've got pi over 8. And if I take a look and see that pi over 8 times 2 is going to equal pi over 4, then I'm looking at double angle identities. The 2 times the tangent, 1 minus the tangent squared, that is just going to equal the tangent of 2 times pi over 8, or pi over 4. And the tangent of pi over 4 is 1. Okay, the next couple examples are everybody's favorites. We're going to do some identities. So I got a left side and a right side. Remember, you're going to only work with one side. However, sometimes it's a little trick. You work with both sides, but then your final answer is the one side. Anytime I see a 2 theta and a theta mixed in a problem, I got to get rid of this 2 theta. So I'm going to look at the double angle identity. The sine of 2 theta is 2 sine theta cosine theta. And not a whole lot I can really do with that now. So I'm going to look at the other side, and basically I'm going to try and turn that into the 2 sine theta cosine theta. Then I can go right to that. This actually is the cotangent squared. Okay, so looking at the right-hand side, 1 plus a cotangent is squared. Well, I caught a cosecant is a Pythagorean identity. So I know that that's cotangent. 1 plus a cotangent squared of theta is just equal to the cosecant of theta. So this side is 2 cotangent theta all over the cosecant squared of theta. So let's take everything now and change it to sines and cosines. The cotangent is the cosine of theta over the sine of theta. That's divided by the cosecant squared. Well, the cosecant's 1 over the sine, so that's 1 over the sine squared of theta. All right, let's multiply by the reciprocal. So 2 times cosine of theta over the sine of theta, multiplied by the reciprocal 1 over the sine squared, so it's going to be the sine squared of theta over 1. The sine squared of theta, the sine of theta will cancel out one of these sines of thetas, so I'm left with 2 cosine theta sine theta, which is exactly where we wanted to get the sine of 2 theta. Okay, the second example, I got sine of x minus cosine of x squared, and that's supposed to equal 1 minus the sine, 1 minus 2 times the sine. No, that's not what it's supposed to equal. It's supposed to equal 1 minus the sine of 2 theta, or 2x. All right, so I got x's mixed with 2x's, so I'm going to take a look at this. The sine of 2x, well, it's going to be 1 minus 2 times the sine of x cosine of x. And again, nothing I can really do with this side, so I'm going to go ahead and FOIL this out. So I've got a binomial being squared, so that's going to be the sine of x minus cosine of x times the sine of x minus cosine of x. All right. First term, sine squared of x. My inners are going to be minus the sine of x times the cosine of x. The outers is going to be minus the sine of x times the cosine of x, or 2 of those, so minus 2 times the sine of x cosine of x. And the last term is going to be a positive cosine squared x. Well, the last term and the first term here is going to be sine squared x plus cosine squared of x, my Pythagorean identity, which is 1 minus 2 times the sine of x cosine of x. And because I took a look at this side, that's exactly what I wanted it to be. Well, right here, I know that 2 times sine of x is that. So, using the double angle identity, the 2 sine x cosine x turns into the sine of 2x. Okay, take a look on Google Classroom. There should be some work there for you. Please do not hesitate to ask me any questions on the previous ones. I can put up some solutions on Google Classroom. If you need me to work them out, just ask and I'll put them up here. Thank you.